people and not important to others. And so for me, something that's really important is my name. It's something that somehow people frequently get wrong despite the fact that it's written in my email signature. And it annoys me to the point of when my high school spelt my name wrong on the honor board, I went back to the high school several times to have meetings to find out why it had happened and where they'd got the misspelling from my name from, and figuring out how it was going to get fixed. Because while getting a piece of someone's identity wrong to you might not seem like much, to them it could be really painful and annoying. And something else I didn't know was how many people have multiple identities. I would argue that everyone has multiple identities. There's the way they present themselves in interviews, at work, when they're with their friends on the weekends. They're all different. And so I myself have two major identities professionally. There's me as the IT professional, always drinking energy drinks, carrying around my hat everywhere, and always looking for interesting problems to solve. And then my other professional identity is me as the balloon artist, dressed in color, making dad jokes and keeping kids entertained while they wait. And lots of people know about both of these identities, but very few people see them both. And you wouldn't want the professional balloon artist doing bank security, just like you don't want the IT professional at your kid's birthday party trying to keep them entertained. And then something else that took me longer than it should have to learn was what are OAuth and OIDC. I knew they were both related to identity, but I didn't really know what they were or how they worked. And so OIDC, or OpenID Connect, is a protocol that enables sharing of identification information. And it sits on top of OAuth, but I find it's the easier thing to understand. Using OIDC means that you don't need to create a new user account for every different website or app that you go to. And the way it works is you go to the service you want to use, like Spotify, and you'll go to their login screen. And they'll have the button there, login with Facebook. And you click on that, and Spotify sends you over to Facebook. Facebook then asks for your username and password. They verify that it's you. And then they'll send you back to Spotify with a signed token that contains your identity. And so at no time does Spotify need to know what your Facebook password is, but they know your Facebook identity. And the token they send back is an ID token. It comes in the form of a JSON Web Token, or JWT. And it's got a heap of information in it. So at the top's the issuer, and that's who's provided the identity. Then it's got the subject, which is a string that should never change and always relates to that identity, even if any other information in that changes. Then you have the name, and you can also have nicknames, usernames. You can have a combination of them, or you could have none of them if you didn't need them. And then there's the audience, so the application that identity is meant for. And then there's the issued at and expiry times to make sure that that token has a limited life, and if it's stolen, it's got a limited time where it could be used. And if you ever look at JWTs, jwt.io is really good, and it's helped people solve a heap of problems. One of which was where someone was doing their login was failing, they couldn't figure out why, had to look into it, and all their tokens were being issued 30 minutes in the future because they had settings wrong somewhere in time zones. The other protocol, OAuth, it's similar but different. So in OAuth, instead of sharing identity, it lets you delegate access. And so a good example of where OAuth is used is the service if this then that. When you go to if this and that and link your accounts, they don't get your Facebook password, they don't get your Twitter password, but they have access to do things on those platforms as if it was you. And they do this by using access tokens to validate their API requests. And so access tokens look similar to ID tokens, but there's some key differences. They still have the issuer and the subject. They've still got the audience, but they don't contain fields like name. They don't contain any ID fields. They've also got this scope, this field called scope, which dictates what that token's allowed to be used for. So if you have a scope of read timeline and nothing else, that means that you can't use that token to update someone's Facebook status. And another big thing to know about JWTs is they aren't necessarily, big thing to know about access tokens is they aren't necessarily JWTs. So the easiest thing to do is treat them as if they never are a JWT. So the team I was in didn't do that. We didn't look at the spec first. And so what did we put in our tokens? Well, there's an example of our ID token and our access token side by side. And the big thing you might notice straight away is they both look the same. And that meant that our developers, using our system, could accidentally grab the ID token and send it off to an API to make a request. Or they'd start looking inside the access token for user information. And so getting this undone took a lot of time because every time we tried to make a change, it broke something else that was doing something. Then the next issue is we used usernames for our subjects. And in our environment, we had usernames that did change. And so we were going to run into the potential issue where if everyone was using the subject as their unique identifier, we could end up where a user's username had changed, but all their data didn't change with it. And so we could end up with lost data. Then we expanded our system to include more than one user type. So we had colleagues, customers, external sales, and new customers as our 4 user types. And so now we needed an extra field to state what the customer type was. Because without it, we could have 2 users with the same subject, but different customer types. And so now every single API needed to know about these subtypes and work with them. And then the last big issue we made when we built this was not what we put into our tokens, but what we didn't put in. Our scope, so what the token could be used for, was only ever set to the subtype. And so that meant that API developers would start whitelisting application IDs and subtypes to dictate who could do what. And so if you wanted to build a new application, you had to go to all the APIs you wanted to hit and ask them to allow your application ID now. And if you wanted to use an API as a colleague instead of a customer, you'd need to go to them and ask them to update the API to allow colleagues to call it now. And you could do this, and they might do it, but then you'd get hit by the problem of they might not roll it out to production faster than you could. So where did we go wrong? What was the one thing, what was the thing we did or didn't do that caused us all the issues? We didn't know what the specs were, so we didn't follow the specs. And everything that we did wrong, we would have had nowhere near as many issues if we'd just known the specs and followed the specs. And then after we spent time unraveling a whole heap of our issues, one of the things I wanted to add to our ecosystem was enabling 2-factor auth for everything. And so before we started working on this, we looked at one of our applications. So one of the applications we had was a bank mobile app. And looking at this broke my idea of 2-factor for everything. Because if you want to just quickly see your card balance, you don't want to have to log in, use a token. And if you want to send money overseas, you don't want it to be as easy for someone to do as logging in. And so we started working out different ways we could figure out levels of authentication for different requests. So it come down to the fact that you've got the device should be enough to see the account balance. If you can log into the device with, say, a fingerprint or a password, that should be enough to a bank transfer. If you're sending money to another bank for the first time, SMS auth on top of that. And if you're doing an international transfer, which is something that you'd rarely do, you really want your bank to start calling you and asking you if you're sure that that's what's happening. And so two-factor auth on everything would be great for security, but would come at a massive cost of usability. And so speaking of usability, who knows how short a Netflix password can be? Anyone? Any guesses? Empty? It can't be empty.
Oh, good.
Any other guesses?
4 characters?
Yeah, it's 4 characters.
Octa?
The PIN number.
Basically. Because if you think about Netflix, if you get someone else's account, all you can really do is start watching things, maybe screw up their recommendations, and look at what they've watched in the past. That's not really that much damage. And could you ever imagine typing that into a TV using just the remote? Now, here's another question for you all. Who owns the identity? So you've got your driver's license, who owns that? Is it the individuals or the issuer? What about your bank account? Who owns your bank account? Your Facebook account? Who owns them? Do you own them, or does the issuer own them? It's the issuer. The issuer owns all the identities that are used in their system. They build the identity to represent you and then give it to you as a basically package, as a parcel to represent you in their system. And how does identity make things easier? If you were like my team and made all the mistakes and had to spend lots of time on doing it, identity doesn't make anything easier. It makes it harder because you're constantly unpicking things. But if you do it well, it becomes an enabler. Because if everything in your ecosystem is an authenticated, identified request, you don't need to worry about firewalls between all of your systems blocking traffic, because any request that's made is either fully authenticated or not. And if you centralized all your authentication into one system, instead of each different server having different, or each different application having different service accounts that you need to know about to be able to use it, you've got one central place where you go in, create a new application, create new users, and they're able to use everything that already exists. And then the team I was in, we built pretty much everything from scratch. We used the Identity Server framework, but if we had the option to go back 20 years to when our first identities first started being created, we'd probably go and centralize them somewhere. And instead of building our own provider, use something like Azure AD, social logins, Auth0, because that makes it so much easier, because then you don't need 4 or 5 developers just to build an identity platform. You use someone else's. So if you follow the specs, everything's easy. You need to remember that all your security is variable. It's not it's not the right full security or no security. Some things need less security than others. The issuer, so whoever's providing the identity, owns that identity. And if you do it right, identity makes things easier. Are there any questions?
Correct.
Now, the final thing is the easiest data to protect is the data you don't collect.
Yeah.
Yep.
Wait, done?
I'm done.
I don't want to cut you off before the final slide.
That's the final slide.
Thank you so much. Big round of applause for the commission.